Hello, we're going to start going over 6.3, which is the sums of radicals. And when we look at the sums of radicals, what we have to remember is it's just like anything else that we do. Just as long as we have like terms, that means they can be combined. But if they don't have like terms, then we cannot combine them. So with a radical, right, they need to have the same index, okay, and that same reciproc to be able to combine them. So the first thing we always want to do is simplify anything down that we can. So as we look at example 1, we have 2 times the square root of 50 minus the square root of 243 plus 3 times the square root of 125. So I always want to break down what's on the inside of my radicals first. So 50 breaks down to 25 and 2. 245 breaks down to 49 and 5. And 125 breaks down to 25 and 5, right? So I'm always looking for those perfect squares. So don't forget to bring down any coefficient for any of these. So we need to bring our 2 down, and then we have the square root of 25 would be 5. 2 is not a perfect square, so we're left with the square root of 2, minus the square root of 49 is 7. There is no square root of, well, there is a square root of 5, but it's not a rational number, so we leave it underneath. The square root, then we do plus 3, and then the square root of 25 is 5, and then root 5. So 2 times 5 is 10 root 2 minus 7 root 5 plus 3 times 5, which is 15 root 5. So now we have to look at our like terms. So our like terms are this root 5 and this root 5. So we have minus 7 plus 15 leaves us with plus 8 root 5. And then we bring down our 10 root 2. Now there's nothing that we can combine there, so we're done with our problem at this point. Okay, when we look at problem number 2, 2 times the cube root of 9, there's really nothing we can do with that right now, so we're just going to leave it and we're going to see what else we can simplify down. So 81 is the same as 27 times 3, and the cube root of 27 is 3, and then we're just left with the cubed root of 3. Then with 2 times the cube root of 1/3, remember that 2 times the cube root of 1/3 is the same as 2 times the cube root of 1 over the cubed root of 3. And the cube root of 1 is just 1. So this is really just 2 times 1. So this is minus 2 over the cubed root of 3. But we know we can't leave the cubed root of 3 in the bottom of a fraction. So since we're talking cube roots, we need to get to the perfect cube, which is 27. So we need to multiply top and bottom by the cube root of 9 to get that to be 27. So this would be 2 times the cube root of 9 plus 3 times the cube root of 3. And then here, right, this would be minus, this would be 2 times the cube root of 9 over the cubed root of 27, which is just 3. Now, this is 2 times the cube root of 9. This is 2/3 times the cube root of 9. Now, if it helps you, you can write this as 2 times the cube root of 9 plus 3 times the cube root of 3, and then minus 2/3 times the cube root of 9. Some people, that's helpful to them so they can see that this is the cube root of 9 and this is the cube root of 9, which means you can pull them together. So you have 2 minus 2/3. So remember, 2 is the same as 6/3. So this is really 6/3 minus 2/3, which gives you 4/3 times the cube root of 9 plus 3 times the cube root of 3. And then there's no more that you can bring together there. Now, if you did want to write this with this on top, so you could also write this as 4 times the cube root of 9 over 3 plus 3 times the cube root of 3. Either one of those would be a perfectly acceptable answer. Okay, number 3, we need to distribute this to each piece. So I need to multiply it by here and here. So remember, we do both the coefficients and the radicals. So negative 4 times 3 is negative 12. 6 times 2 is the square root of 12. Then here we have minus a negative, so it's actually going to be plus, right? Because a negative times a negative gives us that positive. So 4 times 5 is 20. 6 times 3 is 18. And then for right now, we're just going to bring down the 5 root 48. So now that we've distributed that all through, we're going to actually break down and pull out any perfect squares that we can. So this is going to be negative 12, and then 12 goes down to 4 and 3. 18 becomes 9 and 2. And then 48 is 16 and 3. If you can skip this step, you're allowed to. Like if you want to go straight from here to this is negative 12 times 2 root 3 plus 20 times 3 root 2 plus 5 times 4 root 3. If you want to go from this step to this step, I'm fine with that. Just realize on a test or a quiz, right, you can't get partial credit if you made a mistake going from here to here if you don't show me the in-between step. So this is a negative 24 root 3 plus 60 root 2 plus 20 root 3. So now we go back, we have this root 3 and this root 3 that can come together. So we'll bring down our 60 root 2, and then we have negative 24 root 3 plus a positive 20 root 3 leaves us with still a negative 4 root 3. Okay. At this point, let's flip it over. Okay, we've just got a couple more examples to go over. On number 4, okay, this is really based upon how well you see this. If you see right away that there's a square root of 8 that I can pull out of this and a square root of 8 that I can pull out of this, it makes it significantly simpler. So I'm going to go ahead and write this as 3 times the square root of 8 times the square root of 5 plus 2 times the square root of 8 times the square root of 3, all divided by the square root of 8 minus 5. Root 5. And the reason why I did that is I just want you to see, right, you have this square root of 8 here, you have a square root of 8 here, so you can actually pull that out in front and leave this as 3 times the square root of 5 plus 2 times the square root of 3, right? We just factored that root 8 out. But since we also have that root 8 already on the bottom, we don't actually have to get rid of this on the bottom because it cancels itself out. And then make sure you're careful, you a little better than me when you write out that minus so it doesn't just look like part of your square root. So at this point, I really just have 3 root 5 plus 2 root 3 minus root 5. Well, if I have 3 root 5 and I subtract root 5 from it, that leaves me with 2 root 5 plus 2 root 3. And that's all we got. Okay, and then last but not least, on to question number 5. This is a Pythagorean theorem problem, right? Remember that we have a squared plus b squared has to equal c squared in all right triangles. So that's x squared plus 3 root 5 squared has to equal 5 root 3 squared. And because this is multiplication on the inside, this would be x squared plus, and then 3 squared is 9 times 5. And then square the 5 is 25, square root 3 squared is 3. So x squared plus 45 equals 75. We can subtract 45 from both sides. We get x squared equals 30. When we take the square root of this, do we need to worry about the plus or minus? No, right? Because the side of a triangle is not going to be a negative number. The square root of 30, there's nothing that we can simplify down out of that. So we're just done there at that point when we just have the square root of 30. So for homework for you guys tonight, we're going to do the 7 through 43 odd that it says at the bottom, and that's going to be turned in one place. And then you're going to take the true-false quiz that's on the next page, and there'll be a separate turn-in for you to turn that into. And that will also be graded and will go in the book as a graded assignment. So that's your stuff for tonight. Hopefully that was helpful. If you have any questions, let me know.